Hi everyone, welcome to this video on lesson 14 of the Earth and Climate Scheme of Work. This one's on renewable energy resources and it builds on the previous lesson where we looked at generating electricity primarily in fossil fuel power stations. And to come back to our big picture again before we get into this lesson, and as I've been saying all the way through this sequence of lessons, it's really important to keep coming back to this big picture. What we want to talk about is, okay, we've got this great way of generating electricity to power our phones and so on. Really, really helpful. And we do that by burning fossil fuels. But there's a couple of problems here. Problem number one is that fossil fuels, as we saw in the first lesson of this sequence, in the second half of this scheme of work, fossil fuels depend on animals dying, this very long process over millions of years of compaction, intense heat and pressure, chemical change, fossil fuels get formed. As I just said, that process takes millions of years, which kind of means if we use up all the fossil fuels, that's it. We can't wait around a million years. We're going to have to start thinking about some other options. So there's an issue around the formation of fossil fuels, which means fossil fuels are what we're going to see in this lesson. They're a non-renewable resource. Once they're gone, they're gone. They can't be replaced. So that's one problem with burning fossil fuels. The other problem, and really this is what I suppose this is the most important issue that comes out of this scheme of work, which is to do with climate change and so on, is we can explain to students that if we're burning fossil fuels through combustion, that increases the concentration of carbon dioxide in the atmosphere. And they've learned about this at primary school, so they should have some notion that more carbon dioxide in the atmosphere means that's somehow related to global warming and climate change. And we want to stress to them that that's a big problem. So clearly there's these two huge problems with burning fossil fuels, even though we've got this really good technology that we described in the previous lesson to get electricity that way. So the big question we're asking in today's lesson is, well, how to generate electricity. And what we want to do is give students kind of an overview, and again, this is preparing them for their physics GCSE, where they look at energy resources, but we want to give them an overview of all the different ways that you can generate electricity. So the first, I suppose the most kind of the primary way of generating electricity is that somehow you've got to turn a turbine, which, as we saw in the previous lesson, in turn turns a generator. So turn a turbine. And if you need to revisit what a turbine is and how that links to a generator, that was covered in the previous lesson, so you can revisit that with students. But essentially, the problem boils down to this: how can we get a turbine to turn? So we've seen a few ways, or no, we've seen one way of doing that, but we're going to look at a few more ways now. So the first one is by burning stuff. So I'm going to put burning. You could put combustion as well, but you can burn stuff. So we've seen that in fossil fuel power stations. So I can put fossil fuels here like this. And you can tell students there's another way of doing that. We could also burn biofuels or biomass. So that's things like wood, that's things like ethanol, all of those sorts of things. And if I just move my camera down like this, we can just sketch this and give them this overview of what's involved in this sort of this way of generating electricity. And again, I'm just doing sketches here. But these sketches are important because what we want to do is give them an overview of some of the advantages and disadvantages of each of these sorts of things as well. So what I'm going to do is show, what do we put in to a fossil fuel power station or a biofuel power station? Well, we put fuel plus oxygen. There's some sort of fire. I'm not going to draw this in detail, but we get some sort of fire, which leads to, as we saw in the previous lesson, a turbine being turned. So I'll draw my little turbine turning like this, which leads to a turbine being turned. The problem that we have, as we saw in the previous lesson, is that we put fuel and oxygen in, but we get, amongst other things, carbon dioxide plus H2O out. And you can emphasize to students that fossil fuel power stations and biofuel power stations work in exactly the same way. It's just a different fuel that you're putting in, but both of them release CO2 because they both involve burning. So another option we've got is nuclear power. So I'm going to emphasize by not drawing these big towers that are emitting stuff that nuclear power is a bit different, because nuclear power, you put uranium in, and again, they're going to learn about this in detail if they do triple physics, and they'll learn about nuclear fission and so on, but we can say uranium in like this. We don't need to go into details about nuclear reactors, but essentially it gets really hot. So maybe let's draw a little nuclear reactor here. So you put uranium into your nuclear reactor. This gets very hot. Like that, which heats the water and again leads to your turbine being turned. So we're just giving a really brief overview. What matters for us in this case is that we're going to say no CO2 out. So that's really, really important for us today, is that with nuclear power, you put uranium in, no CO2 out. Now you can emphasize uranium, like fossil fuels, there's a finite amount of it. We can't replace it, so once we use all the uranium for nuclear power, that's it, we're done. So it is non-renewable, but it doesn't release CO2, and that's going to be important, especially when they get to their GCSE. The last thing we can look at in terms of turning a turbine is we can use natural resources. I suppose these are all natural resources. Maybe I'm just going to put renewables. I'm going to come back to this idea of renewables in a minute, because I know I need to talk about biofuels as well. But we can just give some renewables. So this introduces what's really new. I mean, nuclear is new, but this introduces the main the main thrust of this lesson, I suppose. So we can look at some of these renewable resources. So the most obvious one is probably wind. And that's where, again, we're coming back to this idea always that all you want to do in these cases, in order to generate electricity, you need to somehow turn this turbine, because that turns the generator, and that's what generates your electricity. How could we get a turbine to turn? Well, we could build a really big windmill, or as it's really called, a wind turbine, and we could let the wind blow on it. So I can show the wind blowing here like this, and then it's going to turn like that. So that's one way of getting a turbine to turn. Another way is hydroelectric. So we could get a big reservoir of water high up on a mountain somewhere, and again, videos and stuff are really, really good for this. We could let the water flow downwards, and then we could put a turbine there. And again, this is how old-fashioned water wheels in mills and stuff used to work. So you might want to start there with something a bit more concrete. But essentially, if the water flows down like this, that causes the turbine to turn. So we can show the turbine turning. So that's another way. And I can add a note to say that this is hydro. I'm just going to put hydro for now. Really, it should be hydroelectric, but we can leave it as hydro for the time being. And then the last way, we can talk about wave plus tidal. I don't tend to distinguish too much between these, because they're both a case of sticking turbines in the sea. One depends on the waves at the surface, one depends on the tides going underneath. But essentially we can say you can stick a turbine in the sea, and somehow the movement of water in the sea, whether it's because of the waves or whether it's because of the tides, will cause that turbine to turn. But what you want to emphasize to students is that in every single one of these cases, what we've been trying to do is get a turbine to turn. And we're trying to find different ways of energy, either by burning stuff, by harnessing nuclear power, or through renewables, so wind and water in these two cases. In every single case here, we've been turning a turbine. And that's the most common way that we try and generate electricity. We can then just draw their attention to a couple of other options that we have. So number 2 is energy from the sun. So I'll put solar. And yeah, they'll be fairly familiar with solar panels. They'll have seen those most likely in primary school. So you can just sketch a kind of black absorbent panel like this, and then draw some kind of light rays coming from the sun, like that. They'll have an idea of what that means. So that's one way, and then you can get a current directly without needing to turn the turbine. And the last one, of course, is geothermal. And the point to emphasize here, is that geothermal is wonderful, but you only really get it in volcanic countries. So what I'm going to do is draw some very rudimentary volcanoes here like this. I might show some gases, sulfurous gases coming out the top here. So these are volcanic countries, and what we're doing here is harnessing the heat from the earth, which again they covered in their lessons on the rock cycle, the fact that you've got the core which is super hot, and so the deeper you go the hotter it is, and especially in volcanic regions you can directly harness that heat to somehow generate electricity. So that's a really quick overview. Now what's going to be important, especially in the subsequent lessons, is that they can kind of categorize these energy resources, and this is really important for their GCSE as well, and not just for their GCSE, also to be informed citizens, and have informed debates about whether we should build a wind farm over here or whether we should build a nuclear power station over there, because these are big important political decisions, as we know. So the three categories that we're going to be drawing their attention to and we're going to be writing about in the next lesson or two are: one, is it renewable or not? So we can emphasize here that the ones that aren't renewable are nuclear and fossil fuels. And just to emphasize the ones that are renewable, that means we can keep using them and keep replacing them. We're never going to run out. That's biofuels. So you might want to talk about biofuels in a bit more detail. So we can grow sugar crops, sugarcane, and so on, and make ethanol from them, or we can just plant more trees. Yeah, that's a way of regenerating it. Even though we can't use that specific fuel again, it's not like fossil fuels where we have to wait a million years. We can wait a few years and we've got some more fuel. And then all of these renewables, so I'll highlight those just to show that they're renewables. So I might put boxes around each of these. And we can also emphasize that, well, the Earth's not going to cool down anytime soon, so geothermal is renewable, as is solar, because yeah, as long as we've got energy from the sun, or if we run out of energy from the sun, then we've got much bigger problems than whether we can charge our iPhone. So they're the renewables. You can also then highlight those ones that release CO2, and really it's just these two that involve burning. So if we're burning something to turn a turbine, that's the one that's going to release CO2. So both of these are CO2 releases, and we've drawn that in the diagram here. The last one to talk about is reliability, and again, that's a concept that students will kind of have a very, very vague sense of what that word reliable means. So it's worth teasing it out, and really getting them to think about that. But the ones that aren't reliable, and I'm not going to label these, but the ones that aren't reliable are solar. And again, this is a relatively straightforward idea to get the head around. Wind, because it's not always windy. Sorry, solar, because it's not always sunny. Wind, because it's not always windy. And wave and tidal, because yeah, certainly wave. You can't always guarantee that you're going to have waves at the surface if it's not windy again. So that's another category that we can use to think about these when we start comparing them, which is what we'll start doing in the next lesson. So there's an overview, and there's some questions on these. Yeah, which goes into a bit more detail. But yeah, that just maps out all of the different energy resources, so we can start comparing them later on.